The last section of chapter 1 is experimental design. So this is going to look at how you actually do an experiment and what the parts are called. So when you're trying to investigate the relationship between variables, to actually look for cause and effect and not just a relationship, you have to do an experiment. So an observational study can tell you if there's a relationship, but to actually be able to say there's a cause and effect, you have to do an experiment. So the explanatory variable is the cause. What is causing this to happen? The response is your effect. So what is causing this response? Explanatory response variable. The treatment is the different values of that explanatory variable. Different values of the explanatory variable. So if I'm doing a study on does having sunburns does smoking cause cancer? The explanatory variable would be smoking. The response would be cancer. Did you get cancer from smoking? And then the treatments would be the different types of smoking. Like, did you smoke cigarettes? Did you smoke cigars? Did you vape? Did you do none? Those are all different treatments, as well as the amounts of each of those. The experimental unit is the person or thing being studied, because sometimes you do experiments on like mice, right? Lurking variables are additional variables that could contribute. So if we're talking about cancer, that could be like tanning, secondhand smoke, health, cancer history, all of those other pieces that may contribute to that cancer outside of the actual experiment. Random assignment is kind of like those random samples before. It's putting people in the different treatment groups randomly. The purpose of that, so it's random to the treatment groups, random to treatments. And the purpose is to spread out the lurking variables. You know, sometimes you can't control that, or you can't know all of them. So by randomly spreading everything out, hopefully you're spreading out those lurking variables. A control group is either someone who's getting a placebo, which we're going to talk about in a second. They're getting no treatment at all, or they're getting the current treatment. So, in a study, if we're doing like a cancer trial or a drug trial, and we know someone has cancer and we're testing a new drug, we're not going to give somebody no medicine. So we're going to give them the current medicine that we know works, and then we're going to give someone else a new medicine that we think might work better. No treatment would be in that, does smoking cause cancer? That would be someone who's not smoking. A placebo is something that looks or smells like the same as the medicine, but there's nothing in it. There's not an actual treatment. So it might be a pill. It might look like a pill. It might taste like taste the same as the pill, but there's no actual medicine in it. It's pretend. But no actual medicine. So if we were doing a headache treatment, medicine, I think that's how you spell it. Sometimes my brain just stops working. There's no actual medicine in it. So I may give group 1 headache medicine A, group 2 headache medicine B, and group 3 the placebo. And they don't know whether they're getting, I'm talking about this blinding, they don't know whether they're getting medicine A, medicine B, or the placebo. But they're just taking one of the 3 pills and they all look the same. Blinding is when you're masking, that's what I was just kind of talking about, to prevent what's called a placebo effect. The brain is a magical thing, and it can heal itself and it can do things just because it thinks it's getting medicine. So think about like little kids when they get hurt and you give them a Band-Aid and they magically feel all better. The Band-Aid's purpose is to keep germs out of the cut and to keep the blood from cuts from getting on other things. So when little kids come up to you and go, oh, I have a boo-boo, and you give them a Band-Aid and it feels better, the Band-Aid, other than maybe the pressure, doesn't actually make it feel better. So when high school kids come into my room and go, oh, I want a Band-Aid, and I look at them and go, no, you don't even have a cut, you're not bleeding, I'm not giving you a Band-Aid. They're like, but it makes me feel better. No, it doesn't. That's the placebo effect. They've trained themselves that a Band-Aid makes them feel better when it really doesn't. In that headache example I was talking about, there are people that will take that placebo and feel better. The headache will go away. Like, it'll actually go away. The medicine didn't do anything, but their body thinks it did. So they use those placebos to eliminate that, like the brain healing itself. So part of it, it's like eliminates the one where, okay, the medicine didn't really work, the body did it itself. It eliminates the people that are pretending to get better, because sometimes that happens. There's all kinds of things. So there's that placebo effect that gets taken away when some people are actually not taking real medicine. Or the fact that your body really can just heal itself. So a single blind study is when the receiver, the person getting the treatment, doesn't know. So those the 3 groups didn't know which of the pills they were taking. Double is when the giver and the receiver don't know. Receiver, don't, and giver. Wow. Receiver and giver don't know. Now, that seems weird, but what happens is the experiment designer will make these packets, like packet A, B, and C, and I will know which group gets which. But the person giving the medicine, like the nurse, just knows they're giving group A these envelopes, group B these envelopes, and group C these envelopes, but they don't know which one's in there. Now, that can prevent them from treating people differently, because sometimes if you know you're giving sick people medicine that might not be as good or might be better, you might treat them differently, and that can affect things too. So depending on the purpose, you might do a single blind or a double blind study to prevent other variables, lurking variables, the way you treat, the way you act, the way you feel. Those are different things that can affect your study. All right, so let's look at some of these things, see if we can apply them in a real life situation. Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 people between the ages of 50 and 84 are recruited as participants. The people are divided randomly into 2 groups. One group will take aspirin, the other group will take a placebo. Each person takes 1 pill each day for 3 years, but they don't know whether they're taking the aspirin or the placebo. At the end of the study, researchers count the number of people in each group who've had heart attacks. So let's see what we have. The population versus the sample. So 400 people between the ages of 50 and 84. So this is just like before with our population and our sample. The sample is the 400 people. The population would be all people in that age range. So between 50 and 84, between 50 and 84. So that part hasn't changed. Experimental units, so these are the people being studied. So that's each of the 400 people. So the sample is all 400 people. Each person is an experimental unit. All right. Now we look at the variables. So the explanatory is the cause. The response is the effect. So they think taking aspirin, that's the cause. Aspirin reduces heart attack. So that's the effect. Reduces heart attack. That's what they're looking at. And then finally, the treatments. So there's two groups, which means there's two treatments. One is actually taking aspirin, and then the other group is taking a placebo. So even though the placebo isn't actually doing anything, it's considered a treatment. So those would be the answers to those questions. All right, let's check it out. Okay, why don't you do the you try? So pause the video if you want and see what you can do. Come back when you're ready. All right, study needs to be conducted on the effect of 3 medicines, A, B, and C, in the height of adults aged 30 to 45. 90 adults were selected and put into 3 groups. So the sample is 90 adults aged 30 to 45, and this would be all adults aged 30 to 45. And then the experimental unit would be each adult in the sample. Okay. We're trying to figure out if the medicine changes the height. So medicine and height. All right. And then the treatments are, so the first group takes medicine A, second group takes medicine B, third group takes medicine C. So treatments are A, B, and C. That's what we got. Okay. Okay, let's look at example 2. The Smell and Taste Treatment and Research Foundation conducted a study to investigate whether smell can affect learning. Subjects completed mazes multiple times while wearing masks. They completed pencil and paper mazes 3 times, wearing floral scented masks, and 3 times with unscented masks. Participants were assigned at random to wear the floral masks first during their... Sorry, my English had a moment. Participants were assigned at random to wear floral masks during the first 3 trials or during the last 3 trials. For each trial, researchers recorded the time it took to complete the maze and the subject's impression of the scent, positive, negative, or neutral. Describe any explanatory and response variables. So the explanatory would be the mask, whether it's scented or not. So that would be like the smell of the mask. And then the response, it looks like they're recording the time to do the maze. Okay. So if the explanatory variable is the smell, the treatment would be floral and unscented. Those are the 2 smells. Okay. Lurking variables. So it's anything other than the mask that could affect the mazes. So I don't know, IQ, if people like mazes, I don't know, if someone really hates floral or likes it, I guess, or allergies, I guess if you're allergic to scent, anything along those lines, anything you can think of that could affect someone's ability to do mazes, if they've done the maze before. Anything like that could go there. Is it possible to use blinding? I'm going to say for the subjects, no. They definitely are going to know whether they can smell something or not. For the researcher, yes. The person doing the timing doesn't need to know which mask they have. Like the person with the timer doesn't know if they have a scented mask or not. But the person with the mask is going to know this is scented or this is not scented. There's no way to hide that. All right. So you try. See if you can figure that one out. Okay, placebo research group conducted a study to find the extent of placebo effects. Group of men randomly selected were asked to take a test before and after taking a pill that induces a mild headache. The pill in half of the randomly selected men was replaced with a similar pill that has no effect. For each trial, they recorded the change in the time it took men to complete the test before and after taking the pill. So, the explanatory would be the pill, and the response would be the time to take the test. Time to do test. And then the treatments would be a pill that causes headache, and then the placebo. All right, so lurking variables, if they already had a headache, pain tolerance, like the ability to do the test anyway, anxiety, anything along those lines. And then, is it possible to use blinding? I would say yes, they did. It's a placebo. Like, as long as you don't tell them whether they have the headache pill or the placebo pill, then you've used blinding. If the person doing the timing doesn't know which pill, you absolutely could use blinding. All right. A researcher wants to study the effects of birth order on personality. Explain why this study could not be conducted as a randomized experiment. So birth order is like whether you're born first, last, middle child. You can't randomize that. Like when you're going to a group of people, like the oldest is always the oldest. The middle child is always the middle child. There's no way to randomly assign birth order. You could, you can randomly get people and participants, but you can't assign them to the group. The oldest will always be the oldest. So because you can't assign a random experiment, you can't get rid of all or dilute all lurking variables. So you just have to be careful. Like, there are ways to do experiments. You just have to be careful and adjust for variables in a different way. All right. Here's another you try. Check it out. All right. You were concerned about the effects of texting on driving performance. Design a study to test the response time of drivers while texting and while driving only. How many seconds does it take for a driver to respond when a leading car hits the brakes? So, what would be the explanatory and response variables? Well, the explanatory would be texting. That's not how you spell that. Texting. And then the response would be time, seconds to hit the brakes. Seconds to hit brakes. Or the time it hits the brakes, the response time. Any of those words would work there. What are the treatments? So depending on your experiment, you might have done 3 things. You might have done 2 things. So one treatment should have been texting and driving. Another treatment should have been driving only. So you needed at least those 2. You may have come up with more. I don't know what those would have been, but you could have come up with. Okay, what should you consider when selecting participants? So you definitely want to consider some age. You want various ages. You want to look at teens. You want to look at adults. You want to consider gender. You could think about accident history. You want people that have been in accidents before. You want people that haven't been in accidents before. Phone type. A push button phone versus a touchscreen phone. flip phone versus, a phone that doesn't have that. Bigger phones and smaller phones. Anything else you can think of. How often people text. If it's someone that texts all the time versus someone that only texts like once a week. Does voice to text count, or is it only type texting? Those are all different things you could think about. Your research partner wants to divide participants randomly into 2 groups. One to drive without distraction and one to text and drive simultaneously. Is this a good idea? Why or why not? This could go both ways. You could say yes, because it's completely random. That way everyone's in both groups. Everyone's in different groups. It's random which one you end up with. You could do that. You could say, no, it would be better to compare to each other. If you take the same person and compare how they do while texting and without texting, then you have an exact match. There's pros and cons to both. Because then if you're doing the exact match, then they've driven the obstacle course twice. So it's hard, there's no perfect answer. Lurking variables. So let's see, brake lights. Sight issues. Anything else that could affect driving. Is it raining? Are there other distractions besides the texting? Like, what else do we have going on? Is there a difference between newer drivers and more experienced drivers? How could blinding be used in this study? Obviously, the driver is going to know if they're texting or not, but the researcher or the person recording the time, the timer, might not know. All right, so there's some quick reviews of that vocab. All right. Whenever you're doing an experiment on people, ethics is your top priority. It has to be ethical what you're doing for research. It has to be ethical what you're doing to your experimental units. What you present for information needs to be ethical. It is unethical to falsify data. You need to make sure you're using proper methods to collect your data. You need to collect enough data to make sure your data is reliable. It is better to be proven wrong. Come on. Better to be proven wrong than to have false data. Like, if you're proven wrong, oh, well, you're just proven wrong. If you have false data, no one's ever going to trust you. You can make data say whatever you want if you ask the right questions or do it the right way. It's better to report collection. Like, maybe you couldn't get enough data, so you had to change something. Just report it. Like, report, I had to change my method. As long as you report it in your data, people know you're being honest. So you want to report changes, report oddities. That's okay. Like, you're dealing with people. When you're dealing with people, universities have institutional review boards. So like when I got my doctorate, universities, I had to study, like I did a study on students, like on Algebra 2 in my high school classroom. I had to submit my design to an internal review board. They had to approve my process before I did it. And say, like, this is okay. It has to be approved in advance. If it's not approved in advance, you're not supposed to do it. They sometimes will say, do this a little bit differently. Granted, I was just saying, like, hey, I'm going to teach this and I'm going to do this. So, like, it wasn't crazy. But, like, I had to submit, here's what I'm doing. Here's how I'm collecting my data. Here's how I'm storing my data. Here's how long I'm storing it. Here's what I'm going to do with it after a year. Here's how I'm going to destroy it. Like all of the things, like not just how you're collecting the information, but what you're going to do with it and storing it so people's stuff doesn't get out there. You need to minimize risk. So informed consent. Because I was doing high school students, not only did I need my students' permission, I needed their parents' permission. So if the student or the parent said no, I wasn't allowed to include them in my study. So like if the student was excited but the parent didn't want to, couldn't include them. If the parent said yes but the student didn't want to, couldn't include them. So that included like videotaping. You know, if I videotaped my lessons, if the parent said I don't want my child recorded, I couldn't record that class, or I had to like put the video camera up and only record voices. If I was using student work, I couldn't use that student's work. So I had to have signed letters of consent. I had to explain to them that I was keeping it in a locked file cabinet for a year, and after a year I was destroying it. And I explained I needed it for a year so I could write my paper and get my paper approved, and that if that way, like if I had to edit something, I could go back and look at the data again. Like all of that you have to explain and get approved and say, I'm only using this. The only people are going to see that are this person. Like no one's going to see the names other than me, the teacher. Like my professor who's going to edit my paper will never see the names. They will only see the numbers. The informed consent has to be in writing. It can't be verbal. You have to be able to prove that it's there. You have to be able to remove identification risk. So, like their notebooks, their name was on the cover of the notebook, and then once I did my data analysis, I had to rip the covers off. All of those things are part of doing studies so that people can know that their data is safe when you're doing that. So there's a lot of details that goes in to setting up an experiment before you can even start. All right, let's look at these last two. So example 4, describe the unethical behavior in each example and describe how it could impact the reliability of the resulting data. Explain how you can correct it. So a researcher is collecting data in a community. So the researcher selects a block where they're comfortable walking because they know many of the people on the street. So this could be okay. You know, just because you know people isn't a problem. But what could be a problem is if they chose it because they know the answers. So maybe they only went to the block because they knew they were going to get the answers they wanted. So now you've got a convenience. That's not okay. It's not random. So the way to fix that would be to make sure that it's either not everybody you know, so not everyone you know, or it's varied data, or it's not the only block. So you just want to be careful that there's other things than just that one piece that comes from that. All right, let's look at B. No one seems to be home at 4 houses on the route. They do not record the addresses and do not return at a later time and find the residents at home. So what this does is it omits data. Let's say those are working families and those are the only people that work. Now you're cutting out a potential subset. Cuts out a subset. They also don't record that. So by not recording that, you're ignoring that it's cut out. Ignoring it. So a way to fix that is to go back. So you can try again. You could record it. Like if you've tried a couple times and they're still not there, you at least need to record that and say, hey, did this block a bunch of times, could never get these people. So you've at least acknowledged that that's missing. maybe there really isn't anybody that lives there, and then that's okay. But you have to acknowledge that in your report. All right, let's look at C. The researcher skips 4 houses because they're running late for an appointment. When they get home, they fill in the forms by selecting random answers from other residents in the neighborhood. This is false data. This is the worst out of all of it. Not only are you ignoring stuff, you're making stuff up. So, this is really bad. This creates bias. You're omitting a group. So, you skipped houses. You didn't get the full set. You didn't go back, and it's just lying. It's flat out lying. What would be better is to go back later. Or you could try calling if that's an option. Report that it's missing if you can't get back. If you really couldn't get it done that day, you should have not gone and done it a different day. All of those things are better than falsifying data. That's the worst thing you can do. All right, pause the video, do the you try, see how you do. Okay, study is commissioned to determine the favorite brand of juice among teens. Survey is commissioned by the seller of a popular brand of apple juice. All right, so if the seller is the brand of apple juice, that's a biased interest. The intent may be okay, but the fact that they're the seller of the brand could lead people to give false answers. They may be less likely to be honest. You never know. So it'd be better if it was anonymous, if it was someone who didn't have that biased interest, if it wasn't the seller, if it was an outside source. So an outside source would be better. Outside source would be a better commissioner. There are only 2 types of juice included, apple and cranberry. So it's limited. It's not unethical, but it's limited. It's not giving people many choices. A better thing would be more options. Researchers allow participants to see the brand of juice as samples are poured. So there's this thing called brand loyalty. There are people, it's a thing, whether you know it or not, that think they like a brand more just because the brand name. It is true that sometimes some brands taste better than others. There are other times where people really wouldn't know the difference. There's lots of things. So it creates bias. It should be blind. If you're really doing a taste test, it should be blind. Because maybe someone in the study, one of the samples, works for one of the companies. Maybe one of them owns one of the companies. For it to truly be not biased, it should be blind, just to prevent that. It's better, especially if it's part A, where you know who's running the study. You shouldn't know the brand if you truly want non-biased opinions. All right, 25% of participants prefer brand X. 33 participants prefer brand Y, and 42% have no preference between the 2 brands. Brand X references the study in the commercial, saying most teens like brand X as much as or more than brand Y. So if you look at the numbers, 25 like brand X. X is actually less than the 33%. So X is actually less than Y. They're not lying because 42 have no preference. So more people don't care than either. So they're not lying, but it's misleading. They're being misleading. If you're talking apples to apples, X to Y, X is less. They're misleading, but they're stretching the truth. Stretching. Because as much as or more than Y, they can say 42 plus 25 is 67. That's more than 33, so they're not lying, but they're stretching this truth to suit their purpose. So again, not lying, but being overly cautious. So is it unethical? Meh. Is it illegal? No. So be careful what you're looking at and look at all the details is what you kind of want to pay attention to. So that is the end of chapter 1. Let me know if you have any questions.